Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we'll discuss how to find the acceleration due to gravity at certain altitude above the surface of planet. Hello students, let us try to find the expression for acceleration due to gravity when the body is taken above the surface of a planet. That means we are going to find the expression for acceleration due to gravity at altitudes. Now, if I have a planet Earth here, suppose this is Earth planet, its mass is suppose capital M, mass of Earth, R is its radius, suppose this is the R radius, M is its mass. Now if I have a point mass very close to the surface of Earth, then this is the center of Earth. If this point is very near to the surface of the Earth, even 1-2 meter height doesn't matter because this radius is 6400 kilometer and this mass is 610 to the power 24 kilogram. This is the mass of Earth, 610 to the power 24 kilogram. Such a heavy mass and such a large radius, if a point mass is compared to 6400 kilometer, if the object is at a certain height, say 1 to the 10 meter, doesn't matter much. So if I have now this mass, small mass which I have kept on the surface of the Earth is suppose M, small m, and this mass is a capital M, mass of the Earth. Now to find the acceleration due to gravity at certain latitudes, certain altitudes, I have to find the force that is acting on the mass which is present on the surface of the Earth. This mass might be taken to certain altitudes, that is our considerations, but first to start with, that mass is present on the surface of the Earth. So for the mass present on the surface of Earth, for the mass present on the surface of the Earth. Now in this situation, I'm just explaining about this. This mass is, if I apply Newton's law of gravitation, this mass, force on this mass will be towards the center, and force on the planet will be towards the object. This is what we discussed. They are equal in opposite direction. We are concerned with the force experienced by this mass, small mass object that is placed on the Earth surface. So if I have this situation, the center of the Earth with the whole mass is supposed to be concentrated, and at a certain radius, say R, the point mass small m is present. In this scenario, the force acting on this mass is given by Newton's law of gravitation. Suppose this force is F, and it says that force F will be G product of their masses upon the distance square, that is r square. If any object of mass m is subjected to a force of gmm upon r square, then this is the only net force that is acting on it. Obviously, I'm just keeping this mass not exactly on the surface of the earth, just little above it, because in that case I have to consider the normal reaction. To avoid that, I'm just keeping the object at a certain height. Now, this is the net force, and this net force is mass of this object into acceleration that is acting in this direction. So the body is accelerated toward the center of the earth. When the body is accelerated toward the center of the earth, I write that the net force acting equals to mass of the object that is being accelerated and acceleration that is acting, that might be produced, that is produced because of this force. So if I write these two, then because these two forces are same, these two forces are same, and the same force is producing mass into acceleration, these two forces are same. If I do that, equating these two equations, ma equals to g m over r square. Okay, if it is that, then m will cancel out, m will cancel out, a equals to g over r square. This a is called as a small g, that is called acceleration due to gravity. This is the acceleration with which the body will move towards center of the earth, that is denoted by g. So from here, what I am getting is g equals to g over r square. R square. This g is the acceleration due to gravity on the surface of the earth. Okay. So far we have discussed about that g is gm upon r square, and this is the object which is on the surface of a planet. This planet can be any planet. This planet can be any planet. It might be Earth. Now the g on the surface is found to be gm over r square, where g is the universal gravitational constant, m stands for the mass of this planet, and r is its radius. Now, our aim was to find the g at a certain height h above the surface of the earth. That means the body is taken to a height h above the surface of the earth, and at this position the g is represented. To distinguish, this g is represented as g which is on the surface, which is given by this formula. Then g at a certain height h, that is at certain altitude, is represented as g sub h. This means that we are talking about the acceleration due to gravity at a height h above the surface of the earth. So this has to be found. I'll just write down this means the acceleration due to gravity on the surface of earth, gh equal to acceleration due to gravity at a height h above the surface of earth. Now, where our aim is to find this gh, which is gh is given by the same formula you can use, that is gm over distance square that is r plus h the whole square, because this is my r and this object is at a height h. So the total distance from center to this object is small r, I'll call this is r plus h. So this is the point where I want to find the acceleration due to gravity, which is supposed to be this. This is suppose my one equation. The other equation on the surface is gm over r square, because obviously for this point h is 0. If I put h is 0 here, then I'm getting gm upon r square. Excuse me. Dividing these two equations, what I'll get? Dividing equation 1 divided by 2, I'll get gh over g. This value gm over r plus h the whole square divided by gm over r square. So from here, what will cancel is this one, that gm will cancel out, and gh equals to g into r over r plus h the whole square. The whole square. Now this one is the final expression for the acceleration due to gravity at a height h above the surface of the earth in terms of acceleration due to gravity on the surface of the earth. So this is the formula. This is the general formula. We can have also another formula of approximation I can use for that. Mostly it is also used in some certain entrance exam, but this g into r over r plus h can be approximated. So this is when you can use that, when the height is very less compared to radius. So around up to 400 or 500 kilometer, up to 500 kilometer, h is equal to, within that kilometer you can apply approximation, that is g, this r is divided, so this is 1 over h over r square, this is g 1 plus h by r power minus 2, this is g into 1 minus 2h over r. This is the formula that is used when h is less than 500 kilometer with a minimum of error. But this is the general formula you have to use always. Keep in mind that this is the general formula, but this formula can also be used when for quick results, that when it is very less compared to the radius of the earth. So that's all in this expression. But if you want to plot the graph of that also you can discuss. Let me just discuss about the graph also. The graph, that is this gh and acceleration due to gravity g versus the r, distance from the center of the earth. As far as this is concerned, that r is greater than equal to r, that means when the body is on the surface or outside. Suppose this is my r equals to r. So at r equals to r, suppose the value is here g, this is the g value. Outside that, we have just seen that g equals to gm over r square, that means g is inversely proportional to r square. So this graph gradually decreases exponentially like that. This is g inversely proportional to r square. This is how it varies outside that. Okay, so thank you.